So this has something related to rotational stability. Okay, so there are two cases for stable case and unstable case. Okay, so before we go into that, let me just tell you about rotational stability, where it depends on the location of center of gravity G and center of buoyancy B. So center of gravity, we know that is the center of an object. So let's say we have an object, our center of gravity will be somewhere in the middle, so it is denoted by G. But for floating object or fluid, we will have both G and B. So B is the centroid for displaced volume. So it means in for the fluid. Okay, so why does it say displaced volume? If I have an object, I put into water, so the same, this is object, I put into water, I will have the same amount of volume of fluid that it occupy. Okay, so this one will have G, this one we will have we use a center of buoyancy and for object we have center of gravity. Okay, for stable case, our G should be below the point of centroid or center of buoyancy. So our G is below B. So for this case, it is bottom heavy, so we have weight at the bottom. So rotational, any disturbance to the body, any external forces will produce a restoring moment, the one that is mentioned in the previous slide. So will make our body return to original stable position when G is below B. However, for unstable case, our G is above B. So our center of gravity is above center of buoyancy. This means it is unstable. Any disturbance will cause this body to turn upside down. So it is unstable. So for floating bodies, how do we measure their stability? We use this term called metacentric height. Metacentric height, or denoted by GM. So it is say that larger GM, better stability. But where or how do we measure this metacentric height? So metacentric height, GM, is the distance between center of gravity G and the metacenter. So we can see that when G and B is not aligned, so for this case we don't have a metacenter. So for case B and C, we have metacenter. So for this case, when G is above B, we have the metacenter at the top. Okay, so for this case, our metacenter is somewhere between G and B. Metacenter may be considered to be a fixed point for most hull shape, that you can have up to rolling angles up to 20 degree. how do we consider if our body is stable or unstable? So let's look at this. What is the difference between the stable case and unstable case? For stable case, our point M is above point G, thus GM is positive. So this is our point G, our M is higher above point G. So our GM is positive, so it is stable. Any disturbance made to the ship, it will have a restoring moment to bring back the ship to its original position. However, for unstable body, our point M is below point G, as in this case. So we have our M somewhere below point G. So with any disturbance, it will cause the ship to overturn and topple or capsize. Okay, so let me just update this one. Generate an overturning moment. For unstable case or unstable body, as we see in case C, this is unstable because our point M is below point G. So M, instead of located high above like in this case, is located between point G and B. This means our GM, or the metacentric height, is negative. This will generate an overturning moment that will cause the ship to capsize or turn upside down. So overturning moment or restoring moment will happen when point G and point B are not aligned. So when they are not aligned, we will have the line of intersection. We will have the point of intersection. So in this case, the point of intersection here, so from point B to M is this, and point G to M is this. So the point of intersection is denoted as M. So for this case, when B line of action is straight but our G is somewhere there, so the intersection point will be M. So we should know now that larger GM or larger metacentric height will give us better stability. So from here, I can say that we have finished our topic, buoyancy and stability, and then we will continue to the next chapter, which is chapter 4, in another video. Thank you very much.